everyone, I am Dr. Naresh Kumar, Assistant Professor in the Department of Electrical and Electronics Engineering, Institute of Aeronautical Engineering, Hyderabad. Today, we are going to discuss about EMF equation derivation in the DC generator and its related problems. First, what do you mean by DC generator? DC generator is a device which converts from mechanical energy to the electrical energy. Means whenever the principle of DC generator, so rotating conductor placed in a stationary magnetic field, induced EMF will be developed in the armature conductor. So that is the principle according to the Faraday's law of electromagnetic induction. Dynamically induced EMF will be generated in the armature conductors. So first, DC generator. So this is the construction of DC generator. In this, total number of poles here, poles, and this is the field winding, this is the armature conductors. In the slots, these are the conductors and these are the brushes. This one is the commutator and this is the yoke. This is the armature core. Now here, this is a three-dimensional picture of DC generator. Construction of DC generator and construction of DC motor is same, but the working principles are different. The machine which converts from mechanical energy to the electrical energy is known as, that is, DC generator, and the machine which converts from electrical energy to the mechanical energy is known as, that is, DC motor. Now here in this, these are the terms. So first, phi. What do you mean by phi? So phi means flux per pole in the flux per pole. So flux units are Webers. So flux units are Webers. So here number of poles, 1, 2, 3, total number of poles. Flux per pole. Here phi is the flux per pole and Z is the number of conductors, number of armature. This is the armature conductor. This one is the armature conductor. So in this, so number of slots. These are the slots. These are the slots, total number of slots into these are the conductors. Sometimes, so in one slot, 2 number of conductors and 3 number of conductors. So here total number of conductors in the armature is total number of slots and total number of conductors per slot. Sometimes 2 number of slots may placed in the armature slots, and here A, number of parallel paths in the armature. There may be a number of parallel paths in the armature core. Here A equals to 2 for wave winding and A equals to P for lap winding. In case of lap winding, number of parallel paths equals to number of poles. In case of wave winding, number of parallel paths equals to 2 only. This is 2. This is fixed. Here this value is depending on the number of poles. And here P is the number of poles in the DC machine. Here P indicates number of poles. Here 1, 2, 3, 4. And here N is the armature rotation in the RPM. Armature rotation in the RPM, rotating conductor placed in a stationary magnetic field. And induced EMF will be developed in the armature core. So it will rotate. So that rotation in the RPM, that is the speed of the RPM, that is N. And EG is the rotating conductor placed in a stationary magnetic field. Rotating conductor placed in a stationary magnetic field and induced EMF will be developed in the armature conductor according to the Faraday's law and dynamically induced EMF. So that induced EMF induced in any parallel paths in the armature. So these are the phi, Z, A, P and N. Phi is flux per pole in the Webers and Z is the number of conductors and total number of slots, that equals total number of slots into total number of armature conductors per slots, and A is number of parallel paths and P is the number of poles. So Z, A and P only number, there are no units, and phi units are Webers and N units rotations per minute. So this is RPM and EG. So EG is induced EMF, units are volts. Now here the derivation for induced EMF. EMF will be generated in the armature conductors, that induced EMF derivation. So that we will see here. So induced EMF. So induced EMF in any one of the parallel paths. So EG equals to, now we know that according to the Faraday's law. So Faraday's law, rotating conductor placed in a stationary magnetic field and induced EMF will be developed in the armature conductors. EG will be developed in the armature. If it rotates and it is placed in a stationary magnetic field, here armature is rotating and magnetic field is stationary. This the rotating armature placed in a stationary magnetic field and induced EMF will be developed in the armature conductor. That is Faraday's first law. And Faraday's second law, EG. This EG is directly proportional to the d phi by dt, rate of change of flux. So that we will see. Average induced EMF in the conductor, that is d phi by dt. EG is directly proportional to the d phi by dt. That is Faraday's second law. That is in volts. And next thing, flux cut. So here rotating conductor placed in a stationary magnetic field means, so there may be a flux cutting. Flux cuts the conductor and induced EMF will be developed. There may be a change in the flux with respect to the time. Now here d phi by dt, flux cut the conductor in one for one revolution. So at a time only one pole cuts one conductors only one time. So here number of flux cuts the conductor in the one revolution, that equals to phi into p. This is most important. So that is phi into p means that units also in the Webers. Now number of revolutions per seconds, that is number of revolutions means that rotation is n by 60. So time taken for one revolution, that is dt. dt equals to 60 by n. So the reciprocal of n by 60 is, that is 60 by n, that is in seconds. Now here Eg equals to d phi by dt. Eg equals to d phi by dt, and here d phi means phi into p and this is 60 into n. Now here the final equation, generated induced EMF generated per conductor equals to d phi by dt equals to, that equals to, if you simplify this, this is 60 by n, not multiplication here, and this phi n p by 60, this one, that is in volts. Now here there may be a z number of, this is only for one conductor only, for z number of conductors, and a number of parallel paths. Here number of parallel paths, A equals 2 for wave winding and A equals P for lap winding. This is for wave winding and this is for lap winding. Now here simplex wave winding, for number of parallel paths A equals to 2, this one, and number of conductors in series in one path, that equals to z by 2. Now if you simplify that in the previous case Eg equals to P n phi by 60, and here this is a z by 2 for wave winding. And next case for simplex lap winding, this case A equals to P, here number of parallel paths equals to A equals to P, and number of conductors in series in one path equals to z by P. Now here, so now if you substitute in this is z by P and this is z by, so this is the fixed one. So z equals to 2 for wave winding and z equals to A equals to 2 for wave winding and A equals to P for lap winding. Now here the final equation, this is A equals to 2 and A equals to P for wave winding and lap winding respectively, and the final equation, induced EMF in the armature conductor equals to Z and pi by 60 into P by A. Here Z is the total number of conductors in the armature and the armature speed is N, that is in RPM, and flux per pole, that is in Weber, that is 5 and 60, and P is total number of poles and A is total number of parallel paths. Here A equals to 2 for wave winding and A equals to P for lap winding. So the most important formula, this is important in the examination point of view, Eg equals to Z n phi by 60 and P by A into P by A. Now the related problems, let us take some problems. First, a 4-pole generator having wave wound armature winding has total 61 slots and each slot containing 30 conductors. Now total number of conductors Z equals to 61 into 30. Total number of conductors. And what will be the generated voltage in the machine when it is driven at 1500 rpm, assuming the flux per pole to be 8.0 milliwebers. Now here the solution for this one and the given data, flux equals to here 8.0 into 10 power minus 3 webers. And next n equals to 1500 rpm and z equals to 61 into 30, total number of slots into total number of conductors in per slot, and number of poles equals to 4. And here a equals to, what about a number of parallel paths they have mentioned in the question. Wave wound, for wave wound a equals to 2 and for lap wounding a equals to p. Now these are given data. And next the formula for induced EMF, Eg equals to Zn 5 by 60. So now you can substitute in this. If you substitute here, Z equals to this one, this is Z 61 into 30, and this is N, and this one is 8 into 10 power minus 3, that is 0.008 and by 60, and total number of poles 4 and total number of parallel paths A equals to 2 because of wave wound generator, wave wound armature. Now the simplified value, if you simplify this one, that induced EMF equals to 732 volts. Now second problem, a 4-pole DC generator, having wave wound, same type of problem, armature winding has 51 slots, each slot containing 20 conductors. So Z equals to 51 into 20 conductors per slot. Now total number of conductors Z equals to 51 into 20. Now what will be the generated voltage in the machine when driven at 1500 rpm, assuming the flux per pole to be 7. Same, only numericals change here. So the Eg equals to Zn 5 by 60 into P by A. So this is 50, this is Z, and this is the N equals 1500 rpm. So flux equals to 0.007 webers, not in 7.0 milliwebers, and 60, and total number of poles 4 and wave winding generator. Now the simplified value 357 volts Eg equals to. Now next question, a 8-pole DC generator has 500 directly, they have given Z equals to 500 number of conductors, and useful flux is 0.05 Weber per pole. Flux per pole is 0.05. And what will be the EMF generated if it is lap connected? If it is lap connected means A equals to P, total number of poles. A equals to here, total P equals to 8, and A equals to P, that equals to 8, and runs at 1500 rpm. And what must be the speed at which it is to be driven, produce the same EMF if it is wave wound armature. Now here first calculate the EMF. So first calculate. So solution for this, the given data, first Z equals, write down the given data, first 500 total number of armatures, and next N equals to 1200 rpm, and next number of poles equals to 8, and A equals to this is lap wound connected armature, so that A equals to P. A equals to 2 for wave winding and A equals to P for lap winding, so that A equals here 8, P equals 8. So A equals to P equals to 8. Next case, next one, the formula Eg equals to, and the flux phi equals to, what is the phi equals to 0.05 Webers flux per pole, And here if you substitute Z equals to 500, N equals to 1200, and phi equals to 0.05 divided by 60, and this P and A is same, so you can cancel it directly, or you can substitute 8 in place of P and A. Now here 500 Z and this 1200, this N, and this is the phi, and this is P, and this is the A. Now the simplified value, the what is the value, what will be the value here? Eg equals to total 500 volts. Now, so now the here what will be the EMF generated if it is a lab connected and runs at 1200 RPM. And second thing here, if it is a wave connected, what must be the speed at which it is to be driven, produce the same EMF. So same EMF, next thing. So the given data. Next, in the second question, same EMF means Eg equals to 500 RPM. And if it is the A equals to, what is the A equals to, this is for wave wound, this is for lap wound. So they have mentioned here. And remaining parameters are, and what will be the N equals, what is the N value? And don't substitute here N equals. N is, we have to substitute, we need to calculate this N value, speed of the armature. And here same thing here, Z equals to same value 500 and P equals to 8. So what is the formula? Same formula, Eg equals to Z N 5 by 60 into P by A. Here P equals to 8 and A equals to 2 and Z equals to, what is the value? Z equals to and 500, and here phi equals to, what is the value? 0.05. Substitute in this and Eg equals to 5. So sorry, this is Eg equals to 500 volts, not RPM. Now here 500 is the Eg and 500 is the RPM, Z, and N is the which is to be calculated, and this is the flux, and this is the 60, and this is the total number of poles, and this is the total number of armature, number of parallel paths. Here total number of A equals P for lap winding and A equals to 2 for wave winding. Now if you calculate the speed of the armature, that speed equals to 300 RPM. Now next problem. A 4-pole DC generator with wave wound armature has 51 slots, each slot having 24 conductors. Here Z equals to 51 into 24. In the each slot they accommodated that 24 conductors, and the flux per pole, flux equals to 10 milliwebers. And at what speed must be the armature rotate to give the induced EMF 0.24 kilovolts? And what will be the voltage developed if winding is lap connected and the armature rotates at the same speed? Now here the given data first. Here A equals to, what is the A equals to? 2, because it is a wave connected. So this is the wave connected. And P equals to total number of poles, here P. P equals to 4, total 4-pole DC generator, and Z equals to total number of slots into number of conductors per slots, that is 24, and Z equals to 51 into 24. And next thing here, Eg equals to generated EM 240, that is 0.24 kilovolts, that equals to 0.24 into 10 power 3, that equals to 240 volts. And next, what will be the developed voltage if it is winding lap connected? If it is a lap connected, so and the induced EMF. So first, what must be the speed? First you calculate the speed value. What is the speed? So first speed value, and the Eg equals to 240 and Z equals to 51 into 24, and N is we need to calculate, and flux equals to, what is the flux value, and 10 flux equals to 10 milliwebers, 10 into 10 power minus 3 Webers, and P equals to 4 and A equals to 2. So Z, this is Eg, and this one is the flux, 10 into 10 power minus 3, and this is P, and this A equals to 2. This is A, this is P. Now the speed value is 612 RPM. 612 RPM, the rotations per minute. And if it is a lap connected, so what will happen here? So what will be the voltage developed? Eg equals to, and if it is lap connected, so, and the armature speed. So what is the armature speed here? Same thing, this one 240 and 612, and this is 0.01, and this is 4, and this is 4. A equals to P for lap winding, and this is Eg equals to 125 RPM. Next, a 6-pole DC generator has 800 conductors on its armature, and the flux per pole is 0.35 Webers, and the rotation of the speed of the rotation of armature is 1500 RPM, and calculate the induced EMF when it is lap bound and when it is wave wide. The given data solution for this, and Z equals to 800 and P equals to 6 and A equals to 2. First lap wound, this is wave wound, and A equals to P for, that is 6 for lap wound. And N equals to 1500 RPM, and flux equals to 0.035 Webers, means 35 milliwebers. Now what will be the EMF? EMF equation formula is same, Zn 5 by 60 into P by A. Z equals to here 800, and speed equals to 1500 RPM, and this is 35 milliwebers, that is 5, and total number of poles P, and A equals to 2. This is for only wave wound generator. A equals to 2 for wave wound. 2100 volts. And next, for lap wound, A equals to P equals to 6. In this case, same thing, 800 Z and 1500 RPM, N, and this is 5, and this is the P, and this is the A. A equals to P, that equals to 6. A equals to P, that equals to 6, and that induced EMF equals to 700 volts. If it is lap wound, depending on the number of parallel paths, the induced EMF changes. So a 6-pole DC generator has 600 RPM, 600 armature conductor, and useful flux is 0.06 Webers. And what will be the generated EMF if it is wave connected and if it is lap connected and runs at 1000 RPM? Same question, but here the solution same thing. Here A equals to 2 and A equals to P equals to 6, and P equals to 6 and P equals to 6. Z equals to 600 and Z equals to 600, and flux equals to 0.06 and flux equals to 0.06 Webers for lap wave connected and for lap connected. This is for wave connected and this is for lap connected. And next thing here, induced EMF, N equals to 1000, and here N equals to 1000. Eg equals to Zn 5 by 60 into P by A. If you substitute in, this is Z and this is N and this is 5, this is P and this is the A equals to 2, and the value is 1800 volts. And next thing, Eg equals to Z and 5 by 60 into P by A. For lap winding, same thing, Z and 5 by 60 into P. This is the A equals to P, that equals to 6. The value is 600 volts. And next, I hope all these things are clear to you. If you still have any doubts in this lecture, you can comment in the comment section below. I will answer to your queries. Thank you very much to you all.
Like, share and subscribe. Hit the bell icon for more updates.